everyone. Today we're going to be looking at graphing velocity on an incline. Now, we're going to be determining the speed of the car as it rolls down the incline at various points. And we're going to graph that. We're going to have a speed versus time graph. The time will be the independent variable, of course, and speed will be the dependent, as we talked about before. All right, in order to do this, we're going to use photo gate timers. And in case you've never seen one, this is a photo gate right here. There's an infrared beam that goes from the middle of one arm across to the middle of the other arm. And when something breaks that beam, it starts a timer on this data collector. And we will be collecting our data from the data collector and putting it into the data chart on your handout. Okay, so the first thing I need to explain is how I've set up the car. This is one of our cars, and I want you to notice that in the middle of the car is a flag. They call it a flag. It sticks up. This flag is exactly 1 centimeter or 0.01 meters wide. Now that's very important for what we're going to be doing. The car, you may want to get closer for this. The car is going to sit against this screw. The back end of the car sits against the screw. When I let it go, I've positioned the car and the screw so that the front edge of the flag is right almost touching the infrared beam, so that when I let it go, the car starts from rest, breaking the beam at the same time. Okay? Now, we are also going to use a second photo gate, and we're going to start with this one at a location that's 10 centimeters right below the other photo gate. Now, each of these circles on the ramp is 5 centimeters apart. So, 10 centimeters would be right there. Hang on, let's unscrew this. Okay. So now, the two beams are 10 centimeters apart, and when the car breaks the beam and starts the timer, when it breaks this beam, it will stop the timer. So we'll know the time it took to go from 0 to 10 centimeters. Now, the data collector will also tell us how long it took the 1 centimeter flag to break beam B as well. That's what we'll use to determine the speed at this location. Because if it took a tiny fraction of a second for the 1 centimeter flag to go through the beam, then 1 centimeter divided by that fraction of a second will give us the speed at this location. So we'll be able to get not only how long it took for the car to get to each position, but the speed at which it traveled for each position we will be able to calculate as well. And then we can create a graph of speed versus time. All right, so we have it at 10 centimeters. So I'm going to put the car back up here against the screw so that the flag is right in front. Okay, and then I'm going to let it go. Notice I do have a clay ball down there to stop the car so it doesn't bounce and fall off. That would not be good. Now let's look at the data. So here's what you need to write down. You need to write down, just ignore the top one, you need to write down the time it took to go from photo gate A to photo gate B and the time it took the flag to go through photo gate B. We don't need to worry about photo gate A. So just the bottom two right here, put them in the appropriate spots on your table for 10 centimeters. Now, we're going to run the trial again and get 2 more times for how long it took the flag to break the beam. Okay, so we need to do 3 trials for each one to get the speed. We're going to get an average speed. All right, so we'll do it twice more. You're good at this. Here we go. So this is number 2. So we're going to put it right here. The time to go through B. And there's the data over there. We've already gotten A to B. We're getting just this one now, the time for B. Okay? All right, one more time, and then we can get an average for that. There it goes. And right here, the time to go through beam B, write that down. Okay. Now, let's change to a different position. We're going to go to 20 centimeters. So this is 10, 15, 20, right here. And we're going to do 3 trials again. The first trial, we'll write down the time from A to B and the time to B, and then we'll do it 2 more times for this one. Okay? So if you could focus in on the data. Oop, wait, it didn't stop right. Let's try that again. That was a bad run, obviously. It didn't stop for some reason. Okay, here we go. Yes, now that's good. All right, so write down the last 2, the time to go from A to B and the time to break beam B. Okay? Now we'll do it 2 more times quickly. All right, now, again, this time you don't want the bottom one, you want the one in the middle that I'm pointing to. That's the time for the flag to break beam B. All right? One more time for this location. Here we go. All righty. Here's the last one. It only took 0.0084 seconds for the flag to break beam B at 20 centimeters. There you go. So now you've got your 3 TBs. Now let's change the position to 30. And we're going to do 3 more trials again. Okay, here we go. All right. If you could show them the data. You don't need the top one, you just need the TAB and the TB. Okay, here's trial number 2. Okay, now on this one, remember, all you want is the TB. Just the TB. And the last trial for this location. Okay. And again, you want that one right there. Okay, 0.0070. Not bad. Okay. Now we're going to change. Now if you'll notice, it goes from 10, 20, 30, and then it skips to 50. And here's why. The way it's made right here, you can't put the photo gate at 40. It's too fat right here. It won't go up. So we have to jump to 50 on this one, which is okay. I don't have any problems with it, really. Kind of annoying, but it's all right. We'll live with it. Okay, here we go. We're going to do our 3 trials. The first one, you need TAB and TB. Here we go. Okay, if you could show them the data, you need to write down TAB and TB. Okay. Second trial, all we need is TB. Okay, there it is, 0.0056. And the third trial, .0055. Okay? All right, so now we're going to move the position again. Says we need to go to 60. So here we go, 60 centimeters. Okay. All right, on this one you're going to get the TAB and the TB. All right, here they are. The TAB and the TB. 2 more trials to get more TB. Here we go, first one. All we need is the TB now. We've already gotten a TAB. third one. There it is. Looks like 0.0051. All right. Now, the last position will be the 70 centimeter location. So we go down 10 more centimeters to this one. Okay. All right. We need the first run to give us the TAB as well as TB. And there it is. Okay. Okay. Now we need 2 more TBs, so here's the first one. Oh wait, something happened there. It didn't register. Okay, let's try that again. I don't know what happened. Let's zero that. Okay, something's... Oh! There we go. Okay. All right, here we go. Okay, so there's the TAB and the TB. Remember, we don't need the TA at all. All right, 2 more TBs are required. Oh, come on. There we go. Here's the first one. All right, so TB right there. Okay. And the last one for the data table. Here we go. Boom. All right, there it is right there. Wait, that doesn't look right. That's much, much smaller than the other one, isn't it? Let's do that one again. I didn't like that one. That one looked weird. Let's just do it once more, just to be on the safe side. Here we go. Oh, it's the same thing, so it must be okay. So go ahead and put that down. TB, 0.0047. Okay. There we go. We've collected the data. Now your job is to take the data that we've just gotten. You're going to take the 3 TBs and average them. So now you can use the 1 centimeter width of flag with the average time to get the speed at each of those locations. Then you plot a graph of the time from A to B and the speed you just calculated. Just follow the instructions on the analysis. It's going to tell you step by step what to do, okay? If you have questions, message me. Thanks, guys.